Hello, class. Welcome back. Today we're going to go ahead and continue, right, our sections. And we are going to continue section 4.2, right? We're going to start section 4.2, which is going to cover the addition rules for probability, right? For probability. So we're familiar with a few card problems, right? With the 52 cards in a deck, and as well as rolling die, right, from section 4.1. And today we're going to go ahead and continue from there, right? And specifically, we're going to be talking about mutuality and, mutually exclusive, right? So the two definitions we should know, right? The two explanations we should know: if two events are mutually exclusive events, then they have nothing in common, right? There's no intersection, right? As opposed, if you were to say if they are not mutually exclusive, that means that they have something in common, right? There's an intersection, right? So for example, right, determine if the events are mutually exclusive, or if you were to pick a card from an ordinary deck, right? And for visuals, right, I've gone ahead and give this image here, right? But for your exam, you're not going to have this image. All right. Needs to determine if these events are mutually exclusive, right? So let's pick a card from an ordinary deck that, right, I get a 4, right? These are my possibilities to get a 4, and that I get a red card, right? And that I get a red card. So my red cards are going to be up here. All right, and I want to determine do these two events, right, the red cards and the 4s, have anything in common where they both intersect. All right, and yes, right, this is not mutually exclusive because this shaded region here is where they both intersect one another. All right, that part is right there where they both intersect one another, and this is what we're going to be focused on, right, going forward. So let's go ahead and jump to the first example. All right. So I want to go ahead and find the probability that John will have company on the way to school. All right. So we are told here that the probability that John would drive to school is 0.39. The probability that he would ride with his friends is 0.22. And that the probability that his parents would take him is 0.39. Right, he is not allowed to have passengers in the car when he is driving. What is the probability that John will have company on his way to school? All right. Well, in let's go. There's 3 possible options, right? One possible option, if he has company on his way to school, is going to be if he rides with friends, right? If he rides with his friends. So let's go ahead and highlight that green. All right. Why? Well, because he has company, all right? He rides with his friends, there's company. And what would be the other one? Right? If his parents, the probability that his parents will take him, right? Right? And these events are mutually exclusive, right? So my formula here, right, would be the probability of riding with, we'll say, friends, or that his parents drive him, right? And this here would be the probability of riding with friends, right? Riding with friends, added with the probability of parents drive him, right? And the probability of riding with friends, right, that was 0.22, plus added to the probability that his parents would drive him, this is 0.39, right? And let's go ahead and get our calculators, right? Let's go ahead and get our calculators. This here would give me, so the probability that John will have company on his way to school will be 0.61, right? And there was no intersection, right? These were mutually exclusive, all right? So let's go ahead and go on to the next problem. Right, and just to go ahead and be clear, I've gone ahead and provided the formula, right? Our addition rule number 2, right? For the reading we've done in section 4.2. If A and B are not mutually exclusive, then that is the formula. If they are mutually exclusive, right? If they were to be mutually exclusive, then that'll just be the probability of A plus the probability of B. And there's no intersection to take away, right? So the only thing we wouldn't be including from the first row and the second row would be that part right there. All right, like John, all right, the probability problem we just had with John, all right, it was mutually exclusive. So, you know, there was nothing we can take away from that intersection. Addition rule 1. And then we have addition rule 2. All right, let's go ahead and do another example. All right, so you're going to be giving tables, right? You're going to be giving this grid, and you're told that the following doctors were observed on staff at a local hospital. All right, column 1, we have MDs, right? And breaking down those MDs, all right, we have 8 pathology, right? 9 in pediatrics and 15 in orthopedics. So one thing that we need to go ahead and do, right, for this entire section, and it's just, right, to help us visualize exactly what is going on, I want you to go ahead and sum those up. Sum up this column. All right, I'll go ahead and call that total. Let's go ahead and add all the MDs, right? I'm going to give the total value for MDs, right? That's going to be 8 plus 9 plus 15. This gives me 32. And I'm going to add all my doctors of osteopathy, right? Osteopathy. That's going to give me 9. All right. So one thing that I also want to do on the other end is going to be to sum up in everybody in pathology, right? Everybody in pathology, right? Including the MDs and the doctors of osteopathy. So that's going to be 8 plus 1, which is 9. All the pediatrics, that's going to be 13. And orthopedics, that's going to be 19. Right? And one thing that should happen, right? One thing that should happen, let me go ahead and add these up. The column for total here, right? You're going to sum up that column for total, right? 9 plus 13 plus 19, that's going to give me 41. We know we are on the right track. If you were to add up the bottom row, right, 32 plus 9, it should also give you 41, right? If they are not the same, right, something's off with our sums, right? So I would go ahead and check that out, right? So we are told, right, choose one doctor at random, right? What is the probability that she is an orthopedist, right? And let's go ahead and get a highlighter, right? An orthopedist, right? I'm only going to be focused on orthopedist, right? Where am I orthopedist? Right there. Right, here's my orthopedist. But since they're not specifying which type of orthopedist, right, we're going to get the sum, right? The total, right? And it's going to be that. So I'm going to be focused on 19 divided by my overall data, all right? So for A, it is going to be 19 divided by the entire total, which is going to be what? 41, all right? So I'm only focusing on one thing, right? I'm only focusing on one thing, the probability that she is an orthopedist, right? That's going to be 19 divided by 41. And that here gives me 0. We'll do 2 decimal places, right? 6. Okay, all right, pretty straightforward, right? Pretty straightforward. Well, let's go ahead and do part B, right? What is the probability that he is a pathologist, or, there it is, right? The or, that's what we're looking for, or a doctor of osteopathy, right? So let's go ahead and focus on the columns or rows for pathologist, right? Which is going to be here, right? And the doctor of osteopathy. Oh, it does, right? These two intersect. Where do they intersect? At that 1. All right. So what I'm going to go ahead and do now, right? This is P of A or B is equal to P of A plus P of B minus the intersection, right, of whatever A and B intersect one another. All right. So the probability of A, all right, that is going to be the probability of pathologist, right? And in order to get a pathologist, that's going to be a 9 over the grand total, which is 41, right? For the doctor of osteo, right, that's going to go ahead and be, again, the total, 9 over 41. And I'm going to go ahead and subtract the intersection because that was, in other words, I got to take away what was counted twice, right? So that intersection was 1, all right? That 1 right there, that green value. So that minus 1 over 41. And I'm going to add these together. So I have 9 plus 9, that is 18. 18 minus 1 is 17 over 41. What does that give me? This is the probability would be 0.41, and 0.41. Okay, let's go ahead and move on to the next. And example 3, right? We're going to be talking about the complement, all right? The complement and more rules, all right? So let's go ahead and make this a little bit bigger. All right, we are told at a used book sale, 100 books are adult books and 175 are children's books, right? We're only going to be talking about the adult books, right here. We are told that 68 are nonfiction, while 70 of the children's books are nonfiction, all right? If a book is selected at random, find the probability that this book is fiction, all right? Find the probability that this book is fiction, all right? So one thing we can go ahead and do is, all right, let's go ahead and write adult here. I'm going to go ahead and write children's here. All right, and I'm told that they are nonfiction, meaning that there also has to be fiction, right? That there also has to be fiction. So let's go ahead and move this a little bit over. So I have adult, I have children here. So I'm pretty much creating a table like the previous table that we were dealing with, right? Let's say here this is fiction. This is not. All right. Go ahead and create that table. Here. All right. There we go. All right. And I know that it should have a total here, right? A total. I was told that there are 100 total books for adult books, right? That's going to be 100 here. And for children, there's 175. All right. So of the adult books, right, 68 are fiction, right? So in other words, 68 are fiction, meaning how many non-fictions are there? Right? 68 added by what will give me 100, or in other words, 100 minus 68 will give me what I'm missing. That means there's 32. Right. For the children's, all right, they are 70 are nonfiction, meaning what plus 70 gives me 175, or 175 minus 70 will give me what I'm missing, right? That means 105 are 105 are fiction. Let me go ahead and then add the total for my fictions. All right, so my total in fiction would be 68 plus 105. All right, that's going to give me 173. And let me go ahead and add up the other ones. 32 plus 70, this is going to give me 102. All right. And we said, right, these are going to be the magic number here, all right? The grand total of all the books, right, has to be equal for the total on the row and on the column, right? So, and if we were to add those together, you'd see that it's 275, right? 275. All right. So one thing I could go ahead and do now, right, would be find the probability that a book is fiction, right? Well, all the total, right, for part A, the fiction books would just be, right, the total fiction would be 173 total fiction over the grand total, which is 275, right? So that is 173 divided by 275. This here gives me 0.63, right? 0.63. All right. We're told find the probability that it is not a children's book, all right? And that right there is a complement, all right? A negation, all right? Which is written as not something, all right? So in other words, the probability that it is not a children's book, right? You may see it like this, or you may see it with a little c on top, right? The probability that it's not a children's book is equivalent to 1 minus the probability that it is a children's book. All right. So the probability that it's not a children's book is equal to 1 minus the probability that it is a children's book. Right. And looking at the complement, that's much easier, right, to wrap our brain around, right? Not a children's book. Right. What can that mean? Well, just look at the negation, right? Just look at the complement, right? So in other words, those two are the same, meaning I can just worry about finding the probability that something is a children's book, right? And if I look for the total children's book, that is going to be 175 divided by my grand total, which is 275. All right. We know to go ahead and combine these, that one needs to have a common denominator, right? So, and we know that 1 is the same thing as 1 over 1, right? And if they got to have the same common denominator, right, I will multiply the bottom and the top by 275. So this is just 275 over 275 minus 175 over 275. And let's see what does that give me. All right, 275 minus 175. All right, what do you guys get? All right, that's going to give me 100 divided by 275. This here gives me 0.37, right? 0.37. Right. And C, right? What does C say? Find the probability that it is an adult book or a children's nonfiction book, right? Find the probability that this is an adult book, right? Find the probability that this is an adult book, which is, right, it's going to be that, right, because it's focused on that entire column, or a children's nonfiction book. Oh, that's very specific, right? A children's nonfiction book. This is right there, specifically that one right there. Let's do blue. Right there. That one. But I was taking the total sum of the adults, right? There's no intersection there, right? So these are not mutually exclusive, right? Right? These are not mutually exclusive. Oh, I'm sorry. They are mutually exclusive, right? They are exclusive from one another, right? They are exclusive from one another, meaning, where's my marker? Meaning, I would not have to subtract the intersection, meaning the probability of it being an adult book is 100 over 275 plus the probability that it is a children's nonfiction, well, it's going to be 70 over 275. This is 170 over 275. And let's plug that into our calculator. Let's see, what do we get? This here is going to give me 0.62. Very nice, 0.62. So let's go ahead and move on to example 4. Okay, example 4. So here, all right, we're giving another chart. We're giving another chart. And we're told that the chart below shows the number of endangered and threatened species, both in the US and abroad, all right? So we said one thing I want to go ahead and do is write the totals for these tables, all right? Because it really helps us visualize all the information we're given, all right? All right, so I'm gonna go ahead and do this real quick. And here are my values, all right? And remember, the totals for the last column must equal the totals for the bottom row, all right? And if they don't, that means our values are off, and just to double check our work, all right? So, right, the question here states, choose one species at random, find the probability that it is a threatened species and in the United States. All right, so I'm gonna go to that overall second column, right, threatened, and I'm looking for a threatened in the US, all right? And that's just one detail, one piece of information, which is going to be that 67, right? So A is just going to be my 67 over the grand total, which is 811, all right? And what does that give me? That here gives me 0.08. 0.08. And then we're going to have another one now. Choose one species at random. Find the probability that it is an endangered foreign bird, right? That is, it is an endangered foreign bird, right? So that's specific. It's telling me, pretty much it's telling me exactly where to pick, right? So it's telling me to go to, right, to threatened, right? And that it is a foreign bird, right? And that it is a foreign bird. I'm sorry, an endangered foreign bird. I'm sorry, an endangered foreign bird. So it's endangered is going to be in column 1, and specifically, I'm looking for a foreign, right? Foreign what? Mammals, birds, reptiles, amphibians. Foreign bird. It's going to be that value right there. So that here is going to be 178 over my grand total. What does that give me? That there gives me 0.22. All right. So, comparing the first one and the second one, right, for A and B, A was an entire column, B was a specific intersection, right? It was looking for something specific. And let's see C, right? Find the probability that it is a mammal, right? That it is a mammal. Right, so the probability of it being a mammal is going to be 357 over 811, right? So I'm going to be focused on this entire piece, right? That entire piece right there. Or there we go, right? There's an or a threatened foreign species, all right? Threatened, that's going to be column 2. Foreign, the last column. So it's an entire foreign species, right? So that's going to be this entire column over here. There is an intersection, right? My rows and my columns do intersect, right? So that's going to be 357 over 811 plus 49 over 811, right? Because that's my grand total for threatened foreign, minus that intersection where they both intersect is going to be at 23, right? For a foreign mammal. For a threatened foreign mammal over 811. That is my intersection that I'm going to go ahead and get rid of. So let's go ahead and plug that in. Right, and this here gives me 0.47. 0.47. Right, and be sure that we're writing our totals out. If it's a word problem, that was hard. So weird. If it's a word problem, make it into a table, right? Like we did for the previous problem. And if the table is given, just be sure, right? Just be sure that you write the last row in the last column, right? So let's go ahead and move forward to the next example. All right, here, example 5. In a recent year, right? We're told here in the recent year, there were the following numbers in thousands of licensed drivers in the US. All right. So let's go ahead and do my totals column, right? Let's do our totals column. So it's going to be the first thing I want to go ahead and do. Right, we're specifically looking at male and female, and for ages, right? Ages 19 and under, ages exactly 20, and ages at 21. So let's go ahead and fill those spots in. And we're back, right? So these are my totals, right? With the grand total being 15,747. Right, so choose one driver at random. Find the probability that this driver is female and age 21. Female and age 21. So female and age 21, hey, that's good. That's a specific value, right? That's a specific value. So that here is going to be 1627 divided by my grand total, right? 15,747, right? And I know it was a specific value because of the word and, right? Because of the word and. Right. What does this give me? Right. This here gives me 0.10. Right. That gives me 0.10. Find the probability that the driver is age 19 and under, right? Age 19 and under, or male. All right. Oh, or okay. So age 19 and under, right? It's going to be this entire piece here. Or male. There is an intersection, right? There is an intersection. More specifically, right, the intersect right there. All right. So, right, this is P of A or B is equal to P of A plus probability of B minus the intersection of A and B. All right, meaning the probability of A would be age 19 and under, right? So that's 9263 over the grand total, right? 15,747 plus the probability of it being a male, which is 8050, right? Over 15,747 minus the intersection, which is going to be 4746 divided by the grand total. And let's see what does that give us, right? All right, this here gives me 0.80. Right, 0.80. So let's go ahead and board right there. And it says find the probability that the driver is at most 20 years old. right? At most 20 years old. That means, right, that at most it's 20 years old. That means you can have 20 and anything below it, right? 20 and anything below it, right? And I'm talking about a specific row, right? So my two options, right, is going to be the probability of 19 and under, added with the other, the probability of 20, all right? I'm taking all of this into consideration. For the 19, it's going to be 9263 divided by the grand total, which is 15,747, right? And these are just rows, right? I'm talking about one row and another row. The rows don't intersect, so right, so there isn't going to be an intersection that I have to go ahead and subtract from, right? And this here is going to be 3178 all over my grand total. All right, let's go ahead and put this into our calculator. And this here gives me 0.79. 0.79. All right. Okay, we're going to go ahead and move on forward now to example 6. All right. And example 6, right? It talks about the importance of the complement, right? We mentioned I mentioned the complement earlier, all right? So the probability of the complement, right, is equal to 1 minus the probability of just not the complement, all right? So a social organization of 49 members sold college sweatshirts as a fundraiser. The results of their sales are shown below, right? If it's 0 number of sweatshirts, there was 3 number of students, and so forth, all right? So let's go ahead and find this value, all right? Choose one student at random, find the probability that the student sold more than 15 shirts, right? More than 15 shirts. So it's going to be 15 or more, right? It's going to be 15 or more. All right. So we said one thing that we probably want to do from the very start, right? It's going to be, let's create these grand totals, right? Let's go ahead and create these grand totals. And specifically, I want the grand totals for this column right there, right? I want that column right there. So that is going to be, let's go ahead and fill that in. It gives me right there, right? The value is 49, right? So the question asks, find the probability that the student sold more than 15 sweatshirts. 15, right? So more than 15, I'm going to look at these values right there, right? So for A, this here would be 9 over 49, right? Plus 9 over 49 plus 1 over 49, right? 9 plus 9 gives me 18 plus 1, 19 over 49. Let's see what that gives me. This here gives me 0.39, right? Rounding to 2 decimal places, 0.39. All right. And here we go with the importance of the complement, right? Importance of the complement. So I'm told here that find the probability that the student sold at least one sweatshirt, all right? So at least one. So in other words, you can find the probability of all of those, all right? Because at least one had to be sold, right? So you're going to do, right, we can do 15 over 49 plus 12 over 49 plus 9 over 49 plus, whew, that can go on forever, all right? That can go on forever. We can just go ahead and do the complement, all right? If your data wants to focus on all of this, all right, the complement of at least one sweatshirt being sold is what? No sweatshirts being sold, right? So no sweatshirts being sold. And is that in our data? Yeah, it is, right? We have a row for 0 sweatshirts being sold. So in other words, the probability of at least 1 sweatshirt being sold is equal to 1 minus no sweatshirts being sold. All right? That is just going to be 1 minus, what is the probability of no sweatshirts being sold? That's going to be 3 over 49, right? This is 49 over 49 minus 3 over 49, right? Which is 46 over 49, which gives me what? Uh, 0.94, right? Right, 0.94. 0.94. Right. If we were to have done it the other way, right? So let's just say, right, we went to the exam and we had just have extra time, right? Or we just don't see it yet, right? So let's go ahead and prove it, right? So let's do it the long way, right? This is going to be 15 over 49 plus 12 over 49 plus 9 over 49 plus 9 over 49 plus 1 over 49, right? This here is going to give me, all right, 15 plus 12 plus 9 plus 9 plus 1. That gives me 46 over 49, which we know is 0.94. All right. Both are very useful, right? The complement, right? This goes over the importance of the complement, right? So let's go ahead and move on to the next example. Right. I have here a recent study of 400 patients found that 85 alcoholic patients, 57 of them had elevated cholesterol levels, and of 315 non-alcoholic patients, 63 had elevated cholesterol levels. I'm so sorry. If a patient is selected at random, find the probability that the patient is that's a lot of numbers being thrown in there, right? So again, right, for this section, what are we going to do? Oh, it says it up there. Draw a table. All right. So I know that the study talks about 400 total patients. All right. That's gonna come in handy, right? That's gonna come very, very, very handy. All right. So I have patients. I have here alcoholic. Excuse me. I have non-alcoholic. And on this other row, I have elevated cholesterol. Then we have not elevated cholesterol, right? Levels. We said these were going to be my totals, right? My totals. All right. 85 alcoholic patients, right? So that's going to be my total alcoholic patients, right? Which are going to be 85. And I'm told that 57 of those have have high cholesterol levels, right? So 57. Very, very similar to the other problem, right? Like, how do we find that missing piece? Well, we're going to do 85 minus 57. All right. So that means not high levels are going to be 28. We're told for the non-alcoholic patients, right? There's 315 of those, all right? There's 315 of those. I'm told that 63 have high elevated, right? So 315 minus 63, that's going to give me 252 not elevated Okay, let's go ahead and sum my rows. I'm going to do 57 plus 63. That gives me 120. 28 plus 252. That gives me 280, all right? 120 plus 280 gives me 400. And also 85 plus 315 gives me 400. Okay, so this matches with the information that was given to me, right? That there's a total of 400 patients, right? There's a total of 400 patients. So I've gone ahead and created my little table, right? I've gone ahead and created my little table. All right, and I'm told now, find the probability that the patient is non-alcoholic, right? The probability that the patient is non-alcoholic. Well, that's going to be my non-alcoholics total, right? It's going to be 315 over the grand total of 400. Let's see what that gives us. 0.79, right? 0.79. 0.79. For B, find the probability that your patient is a non-alcoholic with non-elevated cholesterol levels, right? So with, all right, that's the word I'm looking for, right? So I'm looking for the column with non-alcoholics, right? It's going to be that second column with non-elevated, right? So this is going to be right there, right? It's going to be right there. So that there's going to be, that's a specific intersection, all right? That's something specific they're looking for. So that's going to be 252 over 400. 400. That gave him 0.63. 0.63. Now they're going to be looking for, let me go ahead and what are they looking for now? They're looking for an alcoholic with high cholesterol, right? Alcoholic with high cholesterol, right? That's going to be I get a 57, right? 57. So that means for C, right? This is, again, it's another just specific value, right? That's going to be 57 over 400, right? And this gives me a 0.14. 0.14. Oh, these were all 3 decimal places. I'm sorry. All right. So going back, that was my, what I have here, my history, 0.788. Right. For this one, that was simply 0.63. So if I want an extra value, I'm going to plug in a 0. And for the one on my history that I just have now, it's 3 decimals. The 4th one goes over. So in other words, this is 0.14, what is it? 3, right? That was 0.143. So again, the importance of drawing the table, right? And the totals. Let's go ahead and move on towards example 8. Very nice. We got more dice, right? More dice. All right. We said for the dice, right, this data is going to be given to you, right? I am going to go ahead and provide that data for you. All right. So what do we have here? Right. 2 dice are rolled. Find the probability of getting the following results. Right. Find the probability of 3 decimal places of finding a sum of 8, 5, or 3. All right. So sum of 8 would be, where would that be? That would be all of these, right? Right. And if we're confused about this, right, I would definitely look into the last video. Right. On the last video, we covered how to break down this table, right? Let's look for the sum of 5s, right? The sum of 5s would be here. or the sum of threes would be there. Very nice. Nothing intersects, right? Nothing that I drew intersects. All right, and we know with the die, all right, there's with this 2 by 2, right, one die and the other one, there's 36 total possibilities, right? So for 8, that's going to be 1, 2, 3, 4, 5. 5 out of 36 plus 1, 2, 3, 4, 36 plus 2 over 36. All right, this is going to give me 5, 9, 11 over 36. What does that give me? 0.305555, so that's going to be a 6, right? Okay. Let's do B. Let me go ahead and clear this, right? Clear this highlighter, right? Let me go ahead and clear that with the highlighter. Let's do this pinkish one, right? Find the probability, all right, of getting doubles or a sum of 5, right? So doubles, right? That means the same value, all right? Like twins, all right? And doubles, right? And where does that happen? Down that intersection. Then down that intersection, right? And getting a sum of 5, right? Getting a sum of 5. Let me go ahead and get a different highlighter. Sum of 5 will happen here, 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 and here. Hey, there are no intersections, right? There are no intersections, meaning for doubles, right? That's going to be 1, 2, 3, 4, 5, 6 over the grand total of 36 plus 4 over 36, right? Which was the sum of 5s, being 10 over 36. Let's see, what does that give me? 0.2777, so 0.278, right? Okay, very nice. Let's go ahead and clear the board, right? Let's go ahead and get green now. Find the probability of a sum greater than 10, right? It doesn't say greater than or equal to, right? So in other words, I'm looking for a sum of 11 or higher, which is going to be here, or higher, right? So it's going to count all these here, right? Because 12 is a sum greater than 10. And or less than 5, all right? So it cannot be 5, right? If it says less than or equal to 5, right? So in other words, it's going to be the 4s, all right? So it's going to be anything less than the 4s. Hey, again, there's no intersection, right? There's no intersection. So for C, this is going to be for the greater than 10, that's going to be 3 over 36 plus the other one is what? 6 over 36, meaning this is 9 over 36. And what does that give me? .25, but if it wants 3 decimals, 0.250, right? Very nice. In case I don't have space, I'll go ahead and do that over there. Right, and now let's see here. Based on the answers to A, B, and C, which is least likely to occur? Well, we know, right? If I'm looking at percentages, right? If I'm looking at A, B in percentage, we said we multiply by 100, right? So the probability of getting a sum of 8, 5, or 3 is 30.6%. The probability of getting a doubles or a sum of 5 is 27.8%. And then C being 25%. The one that's least likely to occur is going to be C, right? C, because that's the lowest percentage, right? And we said we multiply by 100 to see these probabilities because it's easy to visualize with percentages because that's what we're used to. You know, we're used to dealing with these values the entire time, all right, in our lives. So if you play board games, right? If you're playing Monopoly, if you want to see right? If you want to take a chance, or even if you're playing like super, what is it, Mario Party, right? Either on the N64 or on the newest one for the Switch, you can make some great choices, right? It all relates to this class, right? Right. If you want to know, if you want to go ahead and take that risk to see if you're going to land on a golden star, right? You can go ahead and do the mathematics for this, right? To see if rolling that die is going to be a good choice or not, right? Or what's the probability of you getting kicked out of the board, all right? So I hope this was helpful, and thank you very much.